Assalamu alaikum students. Our today's topic is very important. As we discussed in that equations reducible to quadratic form. Before discussing the topic, we have to recall the types of the equation with respect to degree. Number one is linear equation, and that is ax plus b is equal to 0. For example, 3x plus 5 is equal to 0, 2x is equal to 3. Number 2, quadratic equation, that is ax square plus bx plus c is equal to 0. And examples of these are 5x square minus 2x plus 1 is equal to 0, or 4x square is equal to 9 is also a quadratic equation as its highest degree is 2. Number 3, cubic equation, that is ax square plus bx plus c is equal to 0. Examples for the cubic equations are 7x cube minus 2x square plus 5 is equal to 0. 2x cube is equal to 5x minus 3. These are the cubic equations as their highest degree is 3. Number 4, biquadratic equation, and that is ax power 4 plus bx cube plus cx square plus dx plus e is equal to 0. Example for the biquadratic equation are 5x power 4 minus 3x square plus 9 is equal to 0, or x power 4 minus x cube is equal to 7 minus 2x. These are the examples of biquadratic equation as their highest degree is 4. As now we have recalled the types of the equation with respect to degree: the linear equation, quadratic equation, cubic equation, and biquadratic equation. Now we can easily understand the concept equations reducible to quadratic form. There are 5 different types of equations which can be reduced to quadratic form so that we can apply the method of solution of quadratic equations, that is factorization, completing square method, and use of quadratic formula. That will make the solution easy for such kind of equations. Standard form of these 5 types of equations is as follows. Number 1, ax raised to power 4 plus bx square plus c is equal to 0. Number 2, a into polynomial of x plus b over polynomial of x is equal to c. Number 3, ax raised to power 4 plus bx raised to power 3 plus cx square plus bx plus a is equal to 0. Number 4, it may be of two different forms. One is a m raised to power x plus b m raised to the power minus x plus c is equal to 0. And second may be a into m raised to the power 2x plus b into m raised to the power x plus c is equal to 0. Number 5. Fifth equation of the form which can be reduced in quadratic form, that is x plus a into x plus b into x plus c into x plus d is equal to k, where the condition is applied a plus b the constants equal to c plus d. These 5 different forms of equation which are given to us in next exercise, and we have to find the solution of these equations. But before this, we have to use a phenomena. We reduce these equations into quadratic form so that we can apply those methods which we have learned in the previous exercise. We can apply those methods which we have learned in the previous exercise, and these are factorization, completing square, and use of quadratic formula. Students, in this lecture, we learn how to resolve these equations into quadratic form one by one. Let's begin with the first equation, that is in the form ax raised to the power 4 plus bx square plus c is equal to 0, the type 1. In this, we let x square is equal to y. Taking square of both sides, we have x square whole square is equal to y square. X raised to the power 4, 2 to the 4, and y raised to the power 2. We have the values of x square, which is y, and x raised to the power 4, that is y square. Put the value in given equation. In place of x raised to the power 4, we put a into y square plus b. In place of x square, we put y plus c is equal to 0. And that is the standard form of a quadratic equation, the simple standard form of quadratic equation, which we can easily solve by either of the method. Now we move to the type 2 equation which can be reduced into quadratic form, that is a into polynomial of x plus b divided by polynomial x is equal to c. If this kind of equation is given to us, we let the polynomial of x is equal to y, and then put the value of p of x in this equation. We have a into y plus b over y is equal to c. As we have a rational expression in an equation, so therefore we take the LCM of the denominator and multiply each term by it. We have a y into y plus b over y into y is equal to c into y. Y is cancelled by y, and we have a y square plus b is equal to cy. We take this term to the left hand side, and we have a y square minus cy plus b is equal to 0, and that is the standard form on which we can apply either of the method used to solve the quadratic equation. So now we move to the type 3 equation, which can easily be resolved into quadratic form, so that we can apply easy methods of solution of quadratic equation. So let's do it. In the first step, we divide each term of this equation by x square. we have a x raised to power 4 over x square plus b x raised to power 3 over x square plus c x raised to power 2 over x square plus b into x over x square plus a into 1 over x square is divided by x square is equal to 0. To move to the next step, we apply law of quotient of power with same base. The bases are same and the smaller power move to the bigger one. So 4 minus 2 we have x square, a x square. In this 3 minus 2 we have bx and x square is cancelled by x square, we have plus c, and in this small power 1 move to the denominator according to the law, b into 1 over x we have plus a into 1 over x square is equal to 0. We rearrange this equation as ax square and a into 1 over x square. In that we have a common, and in bx and b into 1 over x we have b common. So we rearrange this equation as ax square plus a into 1 over x square plus bx plus b into 1 over x plus c is equal to 0. Now we can take a as common, x square plus 1 over x square. If we take b common in these two terms, we have b into x plus 1 over x plus c is equal to 0. Now, if we let this part equal to another variable y, we have let x plus 1 over x is equal to y. Taking square of both sides, we have x plus 1 over x whole square is equal to y square. Applying formula on the left hand side, we have x square plus 1 over x square plus 2 is equal to y square. This 2 is taken to the right hand side. We have x square plus 1 over x square is equal to y square minus 2. Now we have both of the values, x plus 1 over x and the value of x square plus 1 over x square. And if we put these values of x plus 1 over x and x square plus 1 over x square in this equation, we have the standard form of quadratic equation. We have a, first we put the value of x square plus 1 over x square. In place of that, we get y square minus 2. Then we put the value of b plus b into y, as the value of x plus 1 over x is y, plus c is equal to 0. Now we open these brackets, a y square minus 2a plus by plus c is equal to 0. A y square plus by minus 2a is taken to the end term plus c minus 2a. Now we have all the three terms, as ay square is quadratic term, by is the linear term, and c minus 2a is the constant term for the standard form of quadratic equation. So hence we reduce this biquadratic equation ax raised to power plus bx raised to power 3 plus cx square plus bx plus a is equal to 0 into a quadratic form. Hence we can apply the formula on such kind of equations which are given to us in the next exercise, and we solve such kind of questions. Student, one important thing which we have to discuss in type 3 equation, that is either this form or this kind of form we are given. These two forms are called reciprocal equation. And a reciprocal equation is that in which we replace the value of x to 1 over x. Mean if we make this value x 1 over x, ultimately that will become x. So the equation will remain the same. We get the same result. The equation will not change at that cost if we replace x to 1 over x. So hence such kind of equation, mean the type 3 equation which we discussed, these are called reciprocal equation. Now we discuss the type 4 equation, and that may be of two different forms. One is a m raised to power x plus b m raised to power minus x plus c equal to 0, or a m raised to power 2x plus b m raised to power x plus c is equal to 0. If we require to solve the equations of the form of such kind, then definitely these steps which are told in this lecture, that will help you to solve these kind of questions easily. So let's resolve these two types of equations into quadratic form. In the first step, we apply law of quotient of power with same base on that term. We have a m raised to power x plus b into 1 over m raised to power x plus c is equal to 0. Now we let m raised to power x is equal to y. We put the value of m raised to power x, which is y, in that equation. We have a into y plus b into 1 over y plus c is equal to 0. As we have a rational expression in the second term, so therefore we multiply by the LCM of the denominator to the each term. ay into y plus b into 1 over y into y plus c into y is equal to 0. We have a y square plus y is cancelled to y. We have b plus cy is equal to 0. A y square plus cy plus b is equal to 0. That is the simplified quadratic form, which is actually obtained by reducing this kind of equation of type 4. Now we move to the second different form of the type 4 equation, and that is am raised to power 2x plus bm raised to power x plus c is equal to 0. In that, we let m raised to power x is equal to y, and then after, by taking square of both sides, we got that value of m raised to power 2x. We have m raised to power x whole square is equal to y square. According to law of power, 2 is multiplied to x, m raised to power 2x. We have y square equal to. Now we put the values of m raised to power 2x and m raised to power x to resolve into quadratic form. We have a, in place of m raised to power 2x, we put y square. Whereas in place of m raised to power x, we put y plus c is equal to 0. Hence we have the simplified form of such equations, on which we can apply either of the method used to solve the quadratic equation. Students, if you are given of the equation of the form of type 5, that is, mean you are given a question which is in the form x plus a into x plus b, x plus c, x plus d, where a, b, c, d are constants, and as well as the k is also a constant. Mean the equation in the form of product of such kind, and in which the condition is applied, remember, sum of the constants a and b, c and d is equal. So we can resolve such kind of equations into quadratic form. So let's do it. In first step, as we are given a condition, the sum of a and b and c and d, so we find the product of these two factors in which a and b is present and find the product of these two factors in which C and D is present. X is multiplied to x, we have x square. A is multiplied to x, we have ax. X is multiplied to b, we have bx. A is multiplied to b, we have ab. Into x is multiplied to x, we have x square. C is multiplied to x, we have cx. X is multiplied to d, we have dx. Plus c multiplied to d, we have cd is equal to k. As in these both factors, x is common in the middle two terms, so we take common in these two. We have x square plus a plus b into x plus ab. X square plus c plus d into x plus cd is equal to k. As a plus b is equal to c plus d, so we put the value of a plus b, that is c plus d, in place of that a plus b. I repeat, we put the value of a plus b in place of that is equal to c plus d. We have x square plus c plus d x plus ab into x square plus c plus d x plus cd is equal to k. Now we observe we have the same first two terms in both the factors. So therefore we let in such a form of the equation x square plus c plus d into x is equal to y, and then we put the value of x square plus c plus d x, which is y, in both of these factors. We have y plus ab into y plus cd is equal to k. In the next step, we find the product of these two. We have y into y, y square. ab into y, aby. Then y into cd, we have cdy. Then ab into cd, we have abcd. That is equal to k. In the middle two terms, we have y common, so therefore we take y common in these. Y square plus ab plus cd into y plus abcd. K is taken to the left hand side, that becomes minus k equal to 0. As according to the standard form of quadratic equation, constants are actually taken as one unit. So we write as y square plus ab plus cd into y plus abcd minus k is equal to 0. Now we have the simple quadratic form. So we reduce this kind of given equation into standard form of quadratic equation. I hope you learn different steps which are used to solve, which are used to reduce such kind of equations. These kind of questions need more practice, and again I am very hopeful that you are doing some on regular basis, practicing these sums, and if you have any problem, then you can feel free to ask any question related to these topics. Thank you.